My name is Kim Filiatrault. I'm the founder and CEO of Kimputing, Inc., and we have specialized in test automation software. I have led a team of consultants in the P&C, property and casualty insurance industry. I'm consulting for Guidewire software, which is probably the best, it is the biggest company around software insurance for the insurance industry, with customers such as State Farm and Geico. I'm sure you've heard of them. Many other big companies around the world. What I'm going to talk with you about today is test automation. My background is all technical development. During those 35 years as a private consultant in technical development, I have actually done a lot of testing. And from that, I evolved into developing test automation software where I was working. I've never been formally trained in testing, and therefore I think it's an advantage to me because I've never been hindered by the expectations of what you can and can't do in test automation. So I'm going to show you what we have done around the industry we're working in, but the principles should hold true to testing in general, and that's what I'm going to show you, how we've done it and what we're doing. But I'm not selling you anything because it's for very special industry and it's enterprise only. So I couldn't because we just don't. So I'm going to be looking every now and then. I should probably turn this. I can turn this, right? Turn. I failed the testing. Oh, that's even better. Holding it up in the right place. I failed the testing this morning. I plugged my laptop in to do some work, did some work, got ready to head down for breakfast, and my battery was dead. The plug in the wall was not working, and I didn't even look. So I failed the testing, so maybe I'm not the best tester. We're going to talk about some different things around test automation, and we're going to talk about unit testing, API testing. We're not going to talk about unit testing because that's the low level, which we're really into the end-to-end testing, performance testing. One of the big questions we have is there are lots of frameworks out there, lots of tools out there, but there's nothing that is homogeneous to a way of doing something in a simple process. So we're going to get into all of that. This is not a typical stack for a company, but a lot of these tools will be used in your stack for your company. Certainly not one or two of them. And even in our technology, what we've done is it's not a single stack, it's a bunch of little pieces. But what we're going to show you is how you use that as a single stack, simple stack for the testing side of things, the developers, but then within the architecture, you can support whatever stack you want to use. So effectively, this is the side that your team is going to be working in. Testers should be working with a single environment if they can, and in our case, we chose Java for many reasons. It's a pretty ubiquitous language. It supports many tools out there, so you're not going to limit yourself if you use that as your starting point. And then you have to work with data. Data is the core of what you do for testing, so you can use any type of tool that you want from that perspective, so support anything and everything you can. On the other side, which is the framework we're going to get into, then we actually use these technologies within our process. So you'll see Playwright and Selenium both because you shouldn't have to choose. We don't make our customers choose, they use what they want. Same thing like the endpoint. We talked from a previous conversation about writing reports and producing reports. Well, if you want to use a report portal, which is an open source technology, or TestRail, or Zephyr, you plug in what you want into that process, and the technology should support it. We don't support everything, but we can't support anything. We just have to implement a particular abstraction layer, which is also why we chose Java for its object-oriented capabilities. So this is the basic architecture we're going to be working around. So at the core of it is the technology that you want to be working with. Then you have tests. You have output mechanisms where you're going to be producing reports, including into Excel files, which is what we have one customer doing. And then you have some processes that manage it. We're going to touch briefly, very briefly, on a couple of these, a little bit more detail on some of the other ones. So, and here what I mentioned as well, Selenium, Playwright, we support both. It's just the abstraction. You say, I want to run Selenium this time. Oh, and I'm going to run Playwright this time. They each have their own advantages and disadvantages. So choose what you need, not what you're forced to use. So on the testing side of it, we're specifically going to talk about API testing and UI testing and why those are separated. If you want to do API testing, you're going to use something like SOAP UI or pick one. If you're going to do UI testing, it's going to be Selenium or Playwright or Cypress or Test Cafe or pick one, they're all over the place. So when you use an abstraction layer, it lets you separate it out, and you deal with just saying, I need to do this, and you do it. You don't worry about any of the CSS selectors or the XPaths. You have to take that out of the equation. And there was a comment made at the keynote this morning that I thought was brilliant, and it's our design, is you test the way a person would test. If you emulate the way they test, it will work. And that's the core of the principle if you want to develop a good framework. And so as part of this process, we don't distinguish between, what's the difference between a UI test and an API test? There really isn't. They both require you to put data in, do something. If you're doing an API test, you're maybe calling out a web service, pass it data, get data back. Is it what you want to do? From the UI perspective, you fill fields in on a screen, you click a button to get an action, you make sure the action you get back is correct. And if you take a look at the actual test, they look very similar. And what you'll see in this particular example is we are connecting to two different active browsers at the same time in the same test because you have two different people that might have to interact with each other. On the API, you're going to be going to a service endpoint. From the perspective of this side of the equation, the two different endpoints, one is going to the policy system, and then a second one is going to go to the claim system. So you're going to create a policy, or you're going to go into a policy, do some changes to it, create a claim against it in the claim system. Two interactions within the same single test. That's the way a normal set of people would work together. On the API side of it, you're just going to make the connection to the endpoint. Oh, sorry, what I was showing there is connecting. That's the login process. So now you're going to log in, pass your user ID and password, but not an ID and password, it's role-based. So you're going to log in as an underwriter. You don't have to connect to a person because then if the person's password changes, your test changes. So everything gets abstracted out and you have a much more maintainable environment. And then with the endpoint, you're going to authenticate to it through an authentication process similar to user ID and password. Now we're going to get into, I'm looking at the time because I got to get through a fairly sophisticated process here. Now what we're going to do is look at the actual coding perspective. So you saw that if I go back, UI testing and the API testing looks exactly the same. It's just the endpoint that you're going to is different. You don't have to think about different architectures or different technologies. We're going to now go into the process that takes you into the reusables. What we call reusables is the abstraction layers from an old perspective. And what we're going to do is talk about creating the new account. So one step of the process. And if you actually look at each one of these names, it's one of those things that's also the principle of effectively behavior-driven development, BDD, is you're saying what you want to do. So in our process, it would be logging in, creating an account, creating a policy, and then in this one, it's going to do an auto-claim recovery reserve process. So you're basically saying what you're going to do, and then the data gets passed in. We're going to get into data-driven in just a minute. So going from the new account takes you into the new account reusable, which is your Java code. And then from there, we're going to go into two methods, but we're going to go to the second method of creating an account. It comes down to simple Java code, which does a number of basic processes. And then we're going to go into the set address, which comes down in and starts setting all the fields in the address. And you'll notice there's no selectors in here. It's all hidden. It's just get the country, get the address line, get the postal code, get the city, and go ahead and set information in it. And then what we're going to next look at is the account page. So we're now going to go to the physical structure of the page, which is a further abstraction layer. And that's the core to a good architecture and framework, is abstracting all the pieces out. So what we're going to talk about first, before we actually look at the page, which will be next, is the concept of generating the pages. And we're going to show you why that's a critical consideration. Within the Guidewire world, they have an entire developer environment that you work from. You create pages, they have constructs in the processes, and pages are built up of smaller pages. It's a very sophisticated architecture. So what we do is we actually go to the Guidewire source code, and we literally strip the source code down to its base elements, and then from that we can build up the entire structure of your page object model. Now, if you think about what a page does, it defines a physical screen element. And if you talk about what a web service does, there's going to be a contract of some kind, how you interact with that element. So in the world of automation, page object models don't mean just physical browser pages, they mean any contract. So even from the API perspective, those are called POMs. The generator will generate all your POMs, plus within the Guidewire world, many other things that we can generate out of the Guidewire source code. And what you will end up with is we're going to take that set address that we had just finished looking at, and that will come down to your page object model. Now within the page object, oh, by the way, this entire presentation is available. There will be a QR code at the end so you can get a video recording of it or the actual page PDFs of it. What we have now is the page object, and within the page object, click, you'll actually see there's the country element tied in to the get country element up there. So that's how you couple them together. And now within here, you actually have the CSS ID. This CSS ID gets generated out of the entire process. So this is where the complexity of the pages come from, is giving you the structure so you can do simple dot notation within Java and get right to the complex CSS ID. Now what was interesting in this morning's talk is this is the maintainability problem that we're going to have. But if you're generating, that maintainability problem disappears. So if your developers move things around on the screen, it's able to accommodate that because when you regenerate, it comes up with the new CSS ID. This comes out of the process. And what I found intriguing is long before AI became popular, people were actually telling me that we have really cool AI and they were wanting to know what it was. There's not a single line of AI in this process or thought of AI in this process. It's understanding patterns, understanding processes, and then building a process to replicate that. That's what we do as people, as humans, is we see something, we recognize a pattern, and then we can use it. So we just had to make sure our process was as sophisticated as it could be to do this. And we still have some mistakes ourselves. We have to go fix them, but that's the process. And this is about, we have found it to be about 99% perfect, and we have a way to simply let you override it if you need to. But this is the secret of the process and maintaining this, and that's part of what we call the self-healing process, because we don't have to maintain these IDs. The other secret to all of this are the widgets. The widgets are what allow us to create each element that's on that physical page and identify this as a date field or a radio button or a text box, and actually understand how that works within the Guidewire world. And it's not just simple widgets, they have some very complex widgets, 3 or 4 elements that make up a widget from their perspective. Retrieving, the last one here is, oh, don't have it on here. I thought there was, it's on the next page. But those give you the secret. A lot of them share capabilities, so there's an inheritance model in this whole process, but it gives you the capabilities to hide all of the implementation away from the person doing the test creations and running the tests and writing the tests. So here's why you need to generate. Within the Guidewire world, over 2,000 pages are the physical pages that a person interacts with at some point along the process. Not every page, but there are over 2,000 distinct pages. Out of that, there's almost 8,000 subordinate elements that make up those pages, what we call inner classes that are generated to support all of those 2,000 pages. And what's really scary, 127,000 distinct CSS selectors within those 2,000 pages. I mean, even if you make it this many, it can be hard to maintain that many CSS IDs. You stick that comma in there, and it's obviously impossible to do. Now, the widgets, again, something that's pretty well unsustainable if you can't at least generate a basis of it and then implement the distinctions between it, which is what we've done, and have a good OO design. Data-driven. Data-driven, I think we've redesigned the way you should do data-driven processing because we've seen it. And it's these big, long rows, or maybe lots of rows, really wide columns, maybe 100, 200 columns of information going into your test. And for us, that's not sustainable. So this is what data-driven looks like from our perspective, and I think it's something that should be designed into every one of them. This is what our test looks like for a data-driven test, what our spreadsheet looks like. Basically, it tells us what we want to do, and we use abstractions. We pick a person. Well, we know what this person's going to be. We know their age, we know their gender, whatever you want from that perspective. It's an abstract concept. It's like a person. When I look at any one of you, I can recognize you as a person, maybe know you personally, but recognize many characteristics of you. So why put those all in a column, set of columns? So we've abstracted that out, and we actually implemented them through an abstraction layer within Excel, which takes us to an account table in this case. So we're going to have some account information, and we're going to have some personal auto information. So this is a personal auto policy in this case. And then what we do is we actually tie it in. So the way we've done it is the column name, when it's prefixed by a hash sign, takes us to that sheet within the table. So if I'm going to Doe 2, I know that's John with minimum data as the description. That's a John Doe with this particular official ID, this cell phone number, and there's more data along the way. So I immediately know what John Doe's characteristics are. And if I want to override any element of that, I can just within the root spreadsheet. I can say with an age of 35 instead of a birth date of this. And we just go down the list. Here's the address information. So I have some California, New Orleans, Texas addresses, and a few more. And then on here, we're going to have the same pattern for drivers. So we have multiple drivers that's simply comma separated. So this is going to be a 2-driver vehicle, 2 registered drivers for the vehicle. And for the vehicle type, so some Corvettes, some Lambos, good taste. I like those kind of cars. So you just put all the information in. It's very easy to override it now. And now all you need to do is simply add more rows to this list with different values that you're going to put in to match all your characteristics, and it becomes something that's very easily managed by the business team. We need a test that does these criteria, and then we're going to pass in this data. And on top of all of that, if there happens to be data missing in one of these columns, it can actually be bypassed during the testing process. So if you don't have data for that, you can simply say it's because we don't expect data for that. And so you don't have to have a unique test just because you do or do not have data in a specific column. So for us, we just handle it internally. So here's an example of the data-driven testing. It's the same test on each side. One is data-driven, one is not. And the distinctions are now is we point to it being data-driven. We point to the main driver spreadsheet we want. That driver spreadsheet, as we saw, points to all the subordinate spreadsheets that are going to be used. And then we simply read it, and then we pass it. So now when we get down to the set address, on this side we had hard-coded values. On this side, we simply pass in our data container, and it's going to retrieve all the columns that it needs for that test. And that means we can now add an extensive number of tests that have different criteria, different types of characteristics, but not have 25 different people, have 3 or 4 or 5 people, maybe just by gender and by age. So in the insurance industry, male, female, unknown, over 65, so senior person, a middle-aged person, a young person, and an out of age, like too young. So you can have 6 or 7 people handle all your characteristics, and you don't have to create 30 or 40 or 50 people, and you end up with data bloat in the typical world for data-driven testing. I don't want to get between us and lunch, so performance testing. This is another consideration, is when you go to performance testing, you're going to use something like JMeter or Load Runner, a different technology. And if you have this test that you want to really use, you can't. You have to rewrite it to fit into JMeter structure or Load Runner structure. But why do you want to do that? We have the test written. So we did the same thing. It's like, we don't need to do it. And in fact, wouldn't a UI test that actually emulates the way people are working through your system be a better measure of performance testing if you're trying to evaluate the system's capabilities to handle people logging in? If you want to do performance testing of an API, sure, that's all in the back end. You want to do performance system that your testing will handle logging into the US Masters. I mean, it's going to be a lot of people logging in. Testing that the back end works is not testing that the front end works. So you do your API, do your UI testing to performance test. Easy to do. What we do is, so any API UI end-to-end test, or you can write a specific test. If there really is something that you want to do, go ahead and just write it, just like any other test. But we use it with performance profiles. So we simply identify, And this is 3 sheets within the same spreadsheet. So when you do a performance test, you say, I want to use this Excel file, but use this profile. So we have 3 different profiles, just as an example. One profile is just time-based. So after you run out of time on this step, go ahead and end those tests while you spin up the next set of tests for the performance. So I want to run under 2 threads for 200 seconds, and then go to 4 threads, then 8 threads to 12 threads. So we're going to ramp up the number of threads, make sure that we do or don't fail, and we eventually can get to a point where we're going to fail it, and then you can do that either the stress test or a load test or performance. What's our handling like? On the other side, you can do it based upon the number of tests that you're running. So I want to run a certain number of tests, or mix and match as you want. And if you do a mix and match, it's going to take the lowest number, and as soon as you exceed that number, then it's going to stop that step and take you on to the next step. And so now use any test you've written. You could write something special, but you can also use what you already have without forcing yourselves to write something special. So reporting. Because you have access to the entire process when you build your own framework, you can do anything you want from it. So we've already talked about Report Portal and TestRail as the example. But we also produce BDD, so if you want to use given, when, then, even though you can read what each step is doing and each test is doing, if you want to use given, when, then, we actually produce given, when, then constructs for you to see exactly what you're doing, telling you which ID was used, which value was overridden, so you can instantly say, I created a policy for John Doe in New Orleans for a 2024 Corvette that was red instead of blue or green or yellow. So you can clearly see that with what we call narratives. We take it backwards. We let you see exactly what you requested if you don't want to see the easily readable test code itself. And analytics is automatic. You don't have to think about what you're doing from an analytics, because every touch of an element, every set is timed. It tells you what was and what is. It tells you if it was an overridden value. So you have complete analytics for you to do trend analysis, coverage analysis. It's almost too much data, but data is everything. So we give you everything. And you don't have to write for it. It's built into the framework if you design the framework properly. I'm getting close. I'm getting right down to the end because this is the last slide. So this is what we've talked about. This is very doable if you throw away the limitations that you've been really forced onto from the perspective of how do we do automation, and instead come from the bottom back up and say, this is what I want to do, how do I accomplish it? Might not be easy, depending on the scale of what you're doing, and what we took on was massive. I didn't realize how big it was when I started doing this years ago. But what we've accomplished, I think, is extraordinary, and the team that I have now working for me is amazing. I mean, they have added a lot to what we do. But you can take this and scale it down smaller if you just think about, what do we want to do? Do I need to use a test stack that is big, like we saw at the beginning, and have expertise in each one of those independent things and make sure everybody understands all of those pieces? Or maybe have a few experts in each one of those? Or do you want to have a process that pulls it all together? So some of the pros and cons. For the testers, is going to be much simplified. They just need to understand Java, and they need to understand your structure on how you define things. And everything else will be done for them. You make a change in one of the reusables, every test picks it up and it continues to work. If you change the flow, it's all picked up and it continues to work. So simplifies testing, realistic test scenarios. That, I think, is a huge consideration. The more you can test, the more realistic that testing is, the better coverage you will have. You'll actually reduce the number of tests you write, but by using good data-driven principles, you're going to increase the number of tests you execute. So we're going to write 3 or 4 tests, but each of those 3 or 4 tests can end up being 100 or 200 tests that are executed with different coverage points. And this is huge. The amount of effort you're going to reduce is huge. We talked about the data, one language. And as you change versions, you change the DOM. Doesn't matter, you just change the way you generate pages. And we actually fixed in 3 days an entire DOM change by the client. Their own testing technology, it took their teams 3 weeks to fix. So I am pretty proud of that. But there's always some cons. You either have to develop it yourself. That will take expertise, that will take effort, that will take some time, and you will have to continue to maintain it. But once you have it in place, it becomes a lot easier to maintain that framework and extend it. I know, it took a lot of work to get it going, but now it's able to maintain it and modify it very, very quickly. And you will need an SDET. You can't just take a developer here or somebody that writes script code and expect them to understand and maintain a framework from scratch. You need to have some expertise and understanding of it. Once you have that, though, you're off to the races. And that's it. So that's my LinkedIn. But if you use this one, it'll take you to a folder that will allow you to download the presentation as an MP4 or as a PDF. And I'll just leave it up here. And I think that gives us a few minutes for questions and answers, even before you run off for lunch. So do we have any questions? Yes? So it is used for Guidewire customers in the P&C casualty insurance industry. It's a very niche. There's 600 customers worldwide, but there are customers like State Farm, Geico, a lot of the different property and casualty insurance, the mutual insurance carriers. Oh, yes. It is developers, and it is testers, so people writing the test code, and then you will have an SDET. So we maintain this with one person, well, two of us, because I still do some test development work. This is maintained by one person now on my team, and from the development team, it's customized to their own environment, but they maintain that themselves. But they're a qualified SDET person. So we support an entire development team of dozens of developers with one SDET with our technology. And the developers run the tests if they want. Some companies, the developers run them. Some companies wait it for the test to run them. And it's all driven into the CI/CD process, which can be run at builds. Whenever they do merge a code base, they can run it. It's really up to them. Most of their testing is in the cloud, which is expensive, so they usually delay testing until getting ready to deploy now. Any further? Yes?
So I saw that you generated that on the time.
Yes. Sorry? Oh. Yes, that generates UIs and product models.
Repeat the question.
Oh, yes. Okay. Sorry. So can you repeat the question and I will read?
I'm trying to understand whether other than the UI,
Yeah.
you also mentioned
Others.
and that API is also based on the source code?
Yes. It's based on, like from a SOAP perspective, you will have your schema. From REST, some of them create schemas, some of them don't. If they don't, then you have to handwrite a structure. You simply say, these are the fields with the type, and then we generate the actual POM out of that. So if you don't have a formal schema of some kind for REST, you have to provide a structure that we can then interpret.
So all of those different type of tasks is all based on the source code.
Correct. The question was, all those tasks are based on the source code? Yes. All of the generation processes are based on source code specifically. And us interpreting the page code, the schema code, and there's some other support stuff that we actually pull out of the source code to generate components to. Yes?
For performance testing, you can mix and match your API and UI.
Yes.
Okay, do you ever find people that have resources on kind of side?
So the question was, do we mix and match our different things during performance testing? So we don't do it just for performance testing. Your end-to-end test can easily mix and match. And a specific example is you will create an account and create a policy during a UI test for UI testing and then do something to it, like change information on it, renew it. But they also do quote testing where you can do a quote through an API call. So you will have some different companies, you see, we'll go get the race from all of these different providers and give it to you. That's done through API or aggregators is what it's called. And so you can actually then do an aggregator test to go to get a quote for somebody, and then what they did is they want to make sure that that return quote would actually be bindable. So you can actually turn it into a policy. So we would actually then do the API test to go out to do the API call to the aggregator, pull back that policy, then continue by using the policy number that was returned or submission number that was returned, and then go load that submission up in the UI, and then take that UI and take it through binding process, and then actually then produce a report or send the email out to the end client, which would be done as part of a test. And that could be also done through, and from that perspective, you can do restarts, you can do things that take time, simply pause the test and have it continue, all sorts of complexities in the insurance world. There was another question beside you as well. Yes.
So when you have performance tests, like support like endurance test, a drone test for 24 hours, is there a way you can monitor the system resources?
Yes. So as part of testing, when I say we keep track of so the question was, can you monitor performance utilization, and can you do a 24-hour test, for example? So how long the test takes, well, you can extend any test anytime you want. So right now, most of our tests take 3 to 4 minutes to run. They're truly UI process testing in the insurance world, so there's no 24-hour tests. But a test can span 24 hours quite easily, where one example of a test is for changing brokers. So when they change the broker that's assigned to a particular policy, they would actually go in and make the broker change. That doesn't actually take effect until the next day, because it actually goes through a batch job to assign that policy to the new broker. So the test will then do the broker change. It will stop the test. It would fail the test, saying, oh, we have to wait until tomorrow. Then the system will go through a date change. Tomorrow the test would be rerun because it had failed. It will now recognize that I'm in a valid date, and then it can take that test and pick it up and keep going. So it would finish the test. That's all done without human intervention. Same thing like a document. If it takes a day for the document to test or to be produced, you can just pick it up and go the next day. You can run that through for performance testing and all of the times that are taken. So we automatically capture all the Chrome analytics data is all saved. Plus we have our own analytics internally for every action that occurs. We have network information is tracked. So there might be something we don't have, but if there is and we can get to it, we'll save it. We don't have everything because we don't know everything that everybody wants, but it's possible to do it all. That's a wrap. So I'll stick around if there are any more questions if anybody wants, but I am now between you and lunch by 2 minutes. So thank you for your time. That's it.